Are we ready? What do you not understand, Kane? Okay, can I see what you have? Can I come and look? So ready? So we don't have, so the first one was we're not following along. The first one is 11 minus 3 and 10 minus 5. You're not paying attention. Next. So this is 8 and this is 5.
Ooh, suck it.
Next. 8 squared. Guys, stop. 5 squared. Equals the square root. Now, do the x minus 3 and y minus 5. Yes. Next.
You see that?
Okay. Are we ready to go into the next one? Okay. Kane, holler at me when do you have that last one? Okay. Okay. Thank you, sir. Okay. So the next question. Development of the circle equation, guided. This is going to be another weird, crazy one. Here we go. So the center of the circle is the order pair 2, 3, contains the point -6, 8. So if I want to find out how long A to B is, well, that's going to be the same thing as, not A to B, sorry, O to B. So we're doing distance 2 minus -6. What happens when you have 2 minus a negative? Thank you. Okay. What about from A to B? That's your Y's. 8 minus. So then do minus a negative again. I'm going to write it in a parenthesis. I'm going to put -6 in a parenthesis. Do you see that? And then this other one is 8 minus 3. Okay. Next. It loves that. Well, what is 2 minus a -6? It's 8. What's 8 minus 3? 5. Notice that this is the same circle. So 8 squared plus 5 squared, 64 plus 25 is 89. So this is the square root, distance formula or Pythagorean theorem, square root of 89. Lost? Pause. Did you say lost or pause? Is everybody there? Okay, good. Everyone's good. Look at my face. Okay, let's go to the next part of this. So now we're writing a subtraction expression for OD and CD. So OD, D is X, the X coordinate is X, X minus, what's the X coordinate of O? 2, X minus 2. Now we have to look at the Y coordinates of CD because that's a vertical. Vertical is your Y coordinates, Y minus 3. Y minus 3. Next. Well, using Pythagorean theorem, that means the quantity of x minus 2 squared and the quantity of y minus 3 squared. Got it? Can I hit next? Okay. Well, write the equation for the circle. It's just that. X minus 3, the quantity squared, plus y, dang it, y minus 3. It's minus 2. I got you. The quantity squared. I'm going back in there and changing that. Equals 89. Submit. Okay. How do we feel about this? Good, Hayden, or no? What is that? What are you showing me that? What button doesn't work? I don't know what to tell you. You probably got something under it. Okay. Shh, don't do that. Next. Circle equations with the distance formula. Let's do this one. Okay, here we go. We have to write an equation for this. So I want to sketch this over here. Don't judge my drawings. So this is the ordered pair, -1, -1. And this is the center. It's the ordered pair, -4, comma, -5. So I'm just going to draw this fabulous little right triangle right there. So this point right here is -1, comma, -5. How do I know that? Well, you can see it right here if you maybe visualize it on your computer, but it's going to have the y coordinate of the point and the x coordinate of the one above it. So we have to use the distance formula to find this and this. Well, they're horizontal and vertical lines. You can just count it, right? So to go from -4 to -1, that's 3 units. To go from -1 to -5, that's 4 units. That's a special right triangle. It's called a Pythagorean triple. You definitely learned this in Math 1, anyone that had me. You definitely learned this in Math 2 because it's all about trig. What numbers, what's the most famous Pythagorean triple?
3, 4, something.
Yes, Max, it is 3, 4 something. It's 3, 4, 5. It's 3, 4, 5. So our equation is x minus -4 becomes x plus 4, the quantity squared. I'm using the coordinates of the center. Plus y minus a -5 becomes y plus 5, the quantity squared, equals your radius, which is 5 units. This is 5 units right here. It's a special 3, 4, 5 triangle. 5 squared is 25. Okay. You see it? Right there. It's up there. Manuel, I've got it projected so you can see it. You got it? Okay. Everybody good with that one? Okay, let's do one more. Find the circle center and the radius of the equation from a conic form. Okay. So here is the equation of the circle. So I don't know why I did that. So remember that if we know the equation of the circle, here's the parent form. X minus h, the quantity squared, plus y minus k, the quantity squared, equals the radius squared. So this doesn't change and this doesn't change. That's like part of the parent formula, just like point slope form. So if you have an x plus something, you have to remember that came from minus a negative h. If you have a y plus something, you need to remember that that came from minus a negative k. Does that make sense? Yes or no?
Yes.
Okay. So the center is, well, this is minus 15. So the x coordinate is 15, but it says plus 8. That really means it came from minus a negative 8. So the y coordinate is -8. The radius, well, what is 144? If 144 equals my radius squared, you just take the square root of it. 12. Are we good with that? Okay. I'm going to do one more. I think I have to do, yeah.
For what we just did,
Uh-huh.
like we're putting it into Desmos, like put the equation, putting in the equation into Desmos, would that make a circle?
It will.
Yeah. Okay.
Okay. So can you guys do the last 3 you think on your own? Or do we need to do them? Look, let's do one of them. It's not hard. So let's look at this equation right here. Where is my center going to be? If I have x, so -7, comma what? -3. And what is my radius? 3, because remember 9 equals the radius squared. So your radius is 3. Does that make sense? So we're going to drag the center to the point -7, -3. And then you drag your radius out 1, 2, 3 units. How do we feel about that? Do we feel good about that? Okay, so you guys feel like you can do the last two on your own? Okay. Can we do the lesson really fast?